Hello and welcome to topic 6 on price elasticity of demand. This is a relatively short topic and is essentially an application of derivatives and maximization or optimization that we saw in topic 5. So we'll look at one specific example of how to use derivatives to optimize or maximize. In this case we'll be maximizing revenue, but we'll be doing it through the lens of elasticity of demand. So let's first talk about our objectives. So let's start by talking about the objectives for this particular topic. In this topic we will define what we mean by elasticity of demand in two different ways. The first way is using percentages, which is a pretty common way to measure elasticity. The next thing we'll do is do some actual computations and some examples of how that gets done. And then we'll move to defining elasticity with growth rates, which is a little bit more closely related to calculus and the ideas of derivatives that we've been exploring in the last couple of topics. And then finally we'll do some computations with growth rates and with calculus for elasticity. So let's go ahead and start with some percentage calculations, but first we'll start with some definitions. So when we talk about elasticity of demand or price elasticity of demand, we're talking about a relationship between how the price of some item is related to the quantity in demand. So it's somewhat like a demand function that we've seen before, but now we're looking at a slightly different relationship. In elasticity of demand, we're looking at the ratio of the percent change in quantity demanded to the percent change in a corresponding price. And so the ratio that we're looking at is comparing the same two quantities that we compare or that we relate in the demand function, but now through a slightly different point of view. Now the basic idea is to ask a simple question. If you increase the price of some item by a small amount or by a certain amount, then what is the corresponding decrease in the quantity in demand? So once again, remember, our assumption is that if we increase the price of something, then we're going to decrease the quantity in demand under this assumption that we have basically a monopoly situation. So our elasticity value is the ratio of these two quantities. We'll divide one by the other, and we'll basically say, all right, if we want to measure elasticity, the way we do this is we look at how the quantity in demand changes, how the price increase changes, and then divide those two. So that's the basic idea. So we're going to work with some examples so that we can see how this actually plays out. Okay, so before we do any sets of calculations, let's do a simple example where the numbers are given to us and explore what those numbers mean. So let's suppose we start with some item that's currently set at a certain price. We decide to raise that price by 10%. And then what we discover is that as a result, the quantity in demand drops by 20%. So the elasticity calculation would look like this that you can see here. The percent change in quantity demand is negative 20 on the top, and it's negative because the quantity in demand is dropping. And then we divide that by the percent change in the price increase, and that's positive because the price is going up. And so that gives me a ratio of -2. So what this basically tells me then is that the change in quantity demand is twice as large as the change in price, proportionately speaking. And the reason we can do this is because we have measured each of those two changes in terms of percent change. So we can say this one is dropping, quantity in demand is dropping twice as fast as the price is going up. So in an elasticity situation, we will normally just ignore that negative sign because we make the assumption that those two quantities, the price and the demand, they operate in those particular directions. Price goes up, quantity and demand goes down, So you're always going to have a ratio that ends up being negative, and we just therefore then just pay attention to the actual number itself, or the ratio. So we'd say here the elasticity is 2. Now that's not always true in all textbooks, but for our particular purposes we'll just say the elasticity value is 2. At this point we want to introduce some terminology. So we'll start with the inelastic situation. So this occurs when your elasticity value is less than 1. Remember, we're ignoring the negative sign that occurs when you divide the two percent change quantities. So if that elasticity value is less than 1, we say that demand is inelastic. So in this situation, if you increase the price, this is going to lead to a smaller or less proportionate decrease in the quantity demanded. So your price is going up, but your quantity and demand is not going down as fast as that price increase. If that's the case, then you can make the assumption that that price increase will increase your overall revenue. So in other words, if you're at a particular price and you raise that price a little bit, then your total revenue will actually go up because the quantity and demand that dropped as a result of that price increase was not as large as the price increase itself. So this is typical for a good or for a service for which you don't have a reasonable substitute, such as medicine. So if you raise the price of medicine by a relatively small amount, you're not going to see the quantity and demand for that item drop significantly or much more quickly than the price increase does, because people need it. They don't have much of a choice there, and so we say that demand is inelastic. In other words, quantity and demand does not respond very well to a price increase. It's pretty rigid. So that's what we mean by the inelastic value or the inelastic situation. So remember, this is the situation where our elasticity value is less than 1. So that fraction, that ratio between the percent change in quantity and demand divided by the percent change in price, is less than 1. And the only time a fraction in its absolute value can be less than 1 is if the numerator is less than the denominator. So what we then have here, if we think about this, is the numerator, the percent change in the quantity and demand, is smaller than the percent change in the price. In other words, some price increase leads to a proportionately smaller decrease in the demand, and so you have the elastic situation. So that's one potential way to think about what's going on here. If that ratio is less than 1, then we have an inelastic situation, and that's because our quantity and demand does not drop as fast. That numerator is not as big as that price increase down in the denominator. Alright, when your elasticity value is greater than 1, when that ratio of those two percent changes is bigger than 1, we call this situation elastic, or we say that the demand is elastic. This is a situation where when you increase the price, it leads to a larger percent decrease in the quantity in demand. In other words, that price increase is not really a good thing because your demand for that object or that good or service drops much more quickly than the price goes up. So in this situation, if you were to implement an increase in the price, then you'd see your overall revenue fall. This is pretty common for products or goods or services where you have many substitutes that are available to the consumer. So simple things like snacks, where you raise the price on one particular kind, people will say, well, I can go and get the same kind of thing over here for a cheaper price, and so the quantity in demand for the good or service where the price went up tends to drop. So this is the situation that we call elastic. So remember here, the elasticity value is bigger than 1. So that means that that ratio of those two percent changes is bigger than 1. If you think about how the ratio is created, on the top you have the percent change in the quantity and demand divided by, on the bottom, the percent change in the price increase, or the percent change in the price. So if the percent change in the quantity and demand is larger than the percent change in the price, then that's where you're getting a ratio that is bigger than 1. Whenever the numerator or the top of a fraction is larger than the denominator, then that's when you have a fraction or a ratio that's bigger than 1. So if your elasticity is bigger than 1, you're seeing larger decreases in demand that correspond to price increases. So the third situation is when the elasticity value is equal to 1. We say here that demand is unitary, or we have unitary elasticity. So this is the situation where when you increase the price, then the corresponding decrease in demand is proportionately equal. So the percent decrease in quantity and demand is exactly equal to the percent increase in the price. So again, think about that fraction. If the numerator is exactly equal to the denominator, both measured in terms of change in percent, then you have a fraction that has to be equal to 1. Whenever the numerator is equal to the denominator, then that fractional value is equal to 1. So in this situation, when elasticity is unitary, then revenue is not going up, it's not going down. So if it's not one of those two things, it has to be level. And so in that situation, your revenue is maximized. So this is the optimization example that I referred to at the very beginning here of this topic, where we are actually maximizing the revenue function in a different way. So in topic 5, we maximized revenue by looking at the marginal revenue function, setting that equal to 0, and seeing what quantity that took place at. Here we're doing it in a slightly different way. We're maximizing the revenue by looking for the spot where you have unitary elasticity. So this table just gives us a quick little summary of the different phrases that we've just reviewed here. Keep in mind that if your e-value is less than 1, we call that inelastic. In that situation, a price increase will result in a total overall revenue increase. If elasticity value is greater than 1, we call that the elastic situation, and a price increase will lead to a revenue decrease. And then if you want to optimize your revenue, then you're looking for your elasticity value to be exactly equal to 1, which we call the unitary elasticity situation. So let's take a look at some examples.